Before presenting the demo, let me quickly run through the slide which explains the features of Socio Crease and the advantages of the same. Socio Crease and ASM. Why users prefer Socio Crease? Because it allows the users to debug the source file at code level by easily tracing the program instruction by instruction. It also allows the user to trace the program with a listing file. To enhance this Socio Trace feature further, zTPFGI provides various Socio Trace options. Here are the Socio Trace advantages. Users can easily debug their code with various debug options. You can also trace the selected members of the SO. For example, if a user has 100 members in his package, he can particularly select few of the members from his package and set the Socio Trace for those members. User can also trace the program with a listing file. Listing file is nothing but the combination of opcode and displacement. User can also trace the program by setting various breakpoints, and user can also view their trace by different types of debug views. Mission trace view, such as mission trace view, variables and watch expression view, or stack view. Let me present the demo how Socio Trace works. Here is my GI open. I'm connecting to the system, which is the test system. You see the system is connecting. Now the system is connected, which shows the message, right? It is connected to system and terminal, and the user can also see the system tab enabled over here. I have different types of programs present in the project view. Before starting the Socio Trace, user need to set the program for Socio Trace. zTPFGI provides various options for setting the Socio Trace. User can also set the Socio Trace right away from their loading process. I'll explain how. I'm selecting multiple programs for setting for the Socio for loading. I've selected all the programs and right-clicking on it and selecting load option. Now the user can see the program is getting loaded with the help of job status window. Click on this job status button. Present in the home tab. Now the user can see the program is getting loaded. Simultaneously, the progressing of the program in the job status window. Now the user can see the load set creation dialog box. As I mentioned, user can set the Socio Trace right away from their load set process. Here are the different types of Socio Trace options. If the user selects none, only the program is loaded and none of the program is set for Socio Trace. If the user selects, the members present in the SO will be set for Socio Trace. For example, if the package is ABC, which contains the members like ABC1, ABC2, ABC3, you can set any 2 or 3 members for setting the Socio Trace. If you select refresh, the previously loaded load set will be refreshed. If the user selects all the programs present in the package will be set for Socio Trace. Now I am selecting the option select and clicking OK. Now the load process has been started. As I said, select members for Socio window will be present where the user can select the members which he want to set for Socio Trace. I am selecting TST5, TST6 and UVA0 program for Socio Trace. The unselected programs can be set for Socio Trace by manually or by right-clicking right-click options. Now, user can see the program set for Socio Crease. Once the program is set for Socio Crease, user can see the lock symbol present in the load set view pan as well as in the editor pan. When you mouse over on this lock symbol, it will be shown that it is ready for Socio Crease. Now, I'm going to trigger the entry for the program to create the ECB. Once the ECB is created, the layout will be changed to Debug Layout. Earlier, the layout was as default layout. In this layout, you can only edit the program and compile, build, load, all the options you can do it in this layout. Once the debug layout is changed, you can view various type of debug pans, various type of debug views in the layout. Here are the various debug control options present in the debug layout. I'll explain what does each option does when I take you through the trace. Variables. Variables is a view where you can see the TPF, all the TPF registers present from R0 to R50 and as well as the EBW and EB0 areas. Whenever the instruction is executed, the registers present in the particular instruction will be highlighted here. And the same way, watches. If you want to monitor the particular register present in the program, you can just add the registers. Just clear all this. You can just add the register by typing it and click enter. Or else you can just highlight the register present in the instruction and right click on it. You'll get an add watch at cursor option. Click on this, the register will be added to the watch variable. So you can monitor the particular registers R3 and R2 whenever you are executing the trace. Call stack. Call stack window will be updated whenever there is any active subroutine present in the program. This is the active resource terminal where you can trigger your entry and the active ECB. If you click this active ECB, you can see the graphical view of the ECB and all the data levels present here. And this is the mission trace pan where the detailed explanation of the instruction will be displayed. Source mode. As I mentioned, GI allows various type of Socio Trace options. This is one of the options. If you click source mode, it will fetch the file from the path and it will set for Socio Trace. Trace options. You can see various type of trace options present here. These are advanced trace options which I explained in our previous webinar where you can refer it from our website. Now let me explain what is each debug control option does. Run. As the name implies, run will completely run the program and displays the output in the output terminal. I am clicking run. Now you can see the output displayed in the terminal. Now again I am triggering the entry. Now an active ECB is created. Run works in the other way if any breakpoint is set in the program. These are the blue dots are the bubbles. Blue dots indicates the executable line. When you click on the blue dot, the blue dot changes to red dot, which indicates that the breakpoint is set. You can also view this breakpoint in the breakpoint list. Click on the breakpoint list. You can view the breakpoint which is set for the program. For example, I've set breakpoint in UVA 0 at the line number 35. You can either check this checkbox if you want the breakpoint to be enabled in your program. If you uncheck this, the breakpoint will be disabled. I'm now checking the breakpoint. If you right click, you can see various breakpoint options. User may use these options as they wish. Now I'm clicking run. It will run until the breakpoint is set. Now the pinkish bar will indicate the executable line. Now it is run till the breakpoint is set. Run to cursor. Run to cursor, run till where the cursor is selected. Now I'm selecting this instruction, detach, and clicking run to cursor. It will run up to the cursor is selected. Branch to cursor. Branch to cursor directly branches to the line where it is selected. It will not execute the previous line. So the user needs to be careful when he is clicking the branch to cursor, which should not interrupt the flow of the program. Now I'm selecting this instruction and clicking branch to cursor. This line is executed. Mission trace view. Mission trace view is a small view pane attached in the debugger area, where you can see the detailed operation of the execution. Step into allows the user to do step-by-step. Click on the step into option. Now you can see this instruction has been traced and the detailed explanation of the instruction present here. That is nothing but the address, displacement of what are the operations done by that instruction and the operands which are passed to that instruction. Step through works the similar way as step into works. If any bash or jazz routine coded in the program, step through completely executes the routine and the control will come to the next NSI. NSI is nothing but the next instruction line. So I'm stepping through. As I said, it works in the similar way as step into works since there is no bash or jazz routine present in the program. Step out is exclusively for C program, which will step out of the function. Step into new ECB. When there is any crency coded in the program, step into new ECB will be available. To exit the ECB, click on the exit ECB option. Exit all ECBs. When there is multiple ECB present, you can just click on the exit all ECB option. Run or trace. Irrespective of any trace option set in the program, it will just completely run the program and display the output. Reset terminal. If you don't want to exit any ECB or if you don't want to click run or trace but you want to exit the process, just click on the reset terminal. Your terminal will be reset and it will be available for the next input entry. Now I'm clicking reset terminal. You can see a warning message over here. Just click OK, which will remove all the ECBs and the terminal will be set for the next entry. This is all about the Socio Trace option. Let me move on to the next topic, multiple ECBs. Multiple ECBs allow users to trace multiple ECBs at a time. There are various advantages present with this multiple ECBs, which allows the users to simplify and speeds up their debugging process, which means that parallel processing. User may have their parent ECB and the child ECB simultaneously and they can do their trace. Multiple ECBs also provides the ability to draft their specified ECBs by setting various trace options. That is, multiple ECB cannot be traced at the source code level, even at the ECB level. zTPFGI allows users to trace up to 20 ECBs at a time, but user can opt to trace only the current ECB which is created at that time. Here are some of the debug options present in the multiple ECBs. The prime debug option is do not debug child ECBs. If you just uncheck this, all these options will be available. But if this option is checked, you cannot avail the other three sub-options. I'll explain what does each option does when I'm presenting the demo. So I'm just exiting the previous Socio Crease. Now I'm triggering the entry for creating multiple ECBs. As I didn't set any of the trace option, I'm just getting the output alone. Moving forward, I'm setting the trace option. If you set all programs, all the programs present in the entry will be traced. If you select selected programs, only the selected programs for that entry will be traced. Click on the selected program. Trace option dialog box will be displayed. Type the program name you want to set for trace. Now I'm typing TST5 and TST6 for the trace. I'm selecting all macros. If you select no macros, it will not set for trace. If the user wants to trace only the particular macro, you can go with the selected macro option. Now I'm selecting all macros and triggering the entry. Now user can see the ECB is created. Now I'm tracing the ECB. By clicking F10. All the debugger to make the user to make the trace more easier for the user, all the debug control options and trace options are combined with all keyboard shortcut keys. When you mouse over on the particular option, you can see the associated shortcut keys for that. I'll show you. Based on this run to trace, you can see the associated keyboard shortcut key for that. Now I'm doing step-by-step trace. Now I'm trying to create up to 20 ECBs. Once 20 ECB is created, zTPFGI will be showing an alert. I'm just trying to create 20 ECBs. You can also see this ECBs by clicking the drop-down arrow button which is present in the active ECB option. Here you can select which ECB you want to be set for debugging, and also these ECB numbers will be displayed in the ECB list option. Click on the ECB list. You can see the ECB list over here, and the red mark indicates that the current ECB is set for debugging purpose. Since I have coded CREMC in my parent ECB, I am switching every time to the parent ECB for creating this 20 ECB. ECBs. It takes some few minutes. I think I'm reaching the 20 ECBs. Yes, now the user can see the maximum, that is the alert message, which shows that transaction reached maximum ECB to trace. Any more created ECB will not be traced. At this time, user need to drop it, that is, user need to exit any of the ECBs present in the view, or else he has to continue the trace without creating any further ECBs. Now I'm just clicking exit all ECB options, which will completely kill all the ECBs. User can see the ECB is getting killed one by one, and the output. Now the terminal is ready for the next input entry. Moving forward, I'll show all the debugger options present exclusively for child ECBs. These options are available in the zTPFGI options dialog box. To avail that zTPFGI options, click on this big Z button, where you can see different types of Z options. Click on this zTPFGI options button, where you can see the zTPFGI options dialog box. In this, select TPF debugger option, where you can see this multiple ECB option window. If the user check do not debug child ECBs, as I mentioned in the slide, we cannot do anything with this sub option, as this is the primary option present in it. So I'm clicking do not debug child ECBs. What this option does is, we cannot debug any child ECBs, but the child ECBs will be created at the background. So I'm just clicking ZTST5. Now I'm doing a trace. User can see the CREMC macro is getting executed, but he cannot see the child ECB is created because you have checked the do not debug child ECB option. So I'm just executing the ECB. Now again click that big Z option, zTPFGI options. Now user can see the zTPFGI option dialog box. I'm just unchecking this do not debug child ECB and clicking create child ECB. When you check create child ECB immediately, the child ECB which is created will be available for debugging purpose as soon as it is created. If you check trace system ECB option, user can also check system ECBs such as core HC, WTOPC, those ECBs in the front end. Do not CREC immediately. Available in the two different forms, CREC macro. Either he can set with the seconds or with the minutes. If it is set with seconds or minutes, he cannot see that ECB immediately. It will extend after the time limit also. Just clicking OK. I'm providing the entry. So it will create the child ECB after the second. For example, if I've coded with 5 seconds, it will extend its time limit after 5 seconds and then the ECB will be created. You can also trace the multiple ECB with a source code level and also with the ECB level. This is all about the multiple ECB option trace. I hope the session was informative and hands-on was given on both Socio Crease and ASM and multiple ECB. Now the webinar session is open for questions. As I mentioned, user can refer these resource centers for further help. Like we have help options present in our zTPFGI tool itself. I'll show you. If you click this question mark, you can see the zTPFGI help window. You can just type the index what you want to search, and that will be enabled. All our webinars recording session are posted in our website as well as in the social media.
Sorry to interrupt, Safi. We have a question here. The question is how to set Socio trace for other person loaded program.
As I mentioned in the presentation, GI provides the option called source mode. If you enable that source mode option, you can just provide the entry, and GI will fetch that file and set the file for Socio trace. User can do Socio trace in that way. I think so. I have answered your question.
Congrats, that's clear with you. The next question I see here is how to include that, the other person's program in my load set view.
Yes. You have an option in the zTPFGI, add SO to source view option. You can just that option, a dialog box will be enabled. Provide the member or the SO which you want to set for Socio trace, and that member will be set for Socio trace. Let's show you how. Click on this option, which is present under the System tab. Socio trace. Drop-down option. Click on the drop-down option. Select Add SO to Source View. You can just type the SO name present here and click OK. The respective member will be added for Socio trace. I hope I have answered for your question. Is that clear?
He's okay with it. I said okay. Thanks, Sophie. That was an informative session. We don't see any more questions. We appreciate your participation. We have many more webinars planned on the Thursday of every month. Please do come back. Thank you all for joining the session. Have a good day.
Thank you. Thank you for your time.